Okay, and welcome back. We are through problem 1 of 4 for today. We just got through the first problem right here, which talks about the molarity of a zero point 0.3 liter solution containing zero point 0.5 moles of NaCl or table salt. We put that into our calculator and realized with sig figs that it is in fact 2.0. Actually, it's just 2 moles molar solution of NaCl. When you're writing these types of things, you have to remember a couple things. First, you need your units. For units for this, you need molarity, which is represented as the big M. And if it gives you what the substance that you care about is the solute, what the solute is, you also have to include that. You do not have to include water. You do not have to include anything that is dissolving. You just need the thing that is being dissolved. Make sure you know the difference. So, let's continue with what we were doing. So, for our next problem, we're asked to calculate the molarity of a 0.289 moles of FeCl3. So, we have moles, we have 0.289 of them. Moles, yeah, you got it. Dissolved in 120 milliliters of solution. Now, I'm saying milliliters. That should be a red flag. Our equation is molarity is equal to moles over liters. We cannot just substitute milliliters. We have to have liters. So the easiest way to do that is to do a conversion. So 120 milliliters on bottom because that's what we're getting rid of, and we have liters on top. Who here remembers how many milliliters are in a liter? It should be 1,000. So for every 1 liter, there's 1,000 milliliters. So dividing anything by 1,000, we're just going to move the decimal place over, giving us 0.120 liters. So now we can just plug everything straight into the equation. So we have 0.280 divided by 0.120 liters. Well, 1.289, my apologies, 2.289. So then we go to our trusty calculators, 0.289 divided by 0.120. And we end up getting 2.408 molar solution. Now, stays in the room, I'm going to go ahead and erase these up here so I can write that out nice and big. 2.408 molar solution of FeCl3. Now, what are we forgetting? Sig figs. We have to include our sig figs. So we have 2.408 molar solution of FeCl3. How many sig figs can we keep? Well, let's look. This one has a assumed decimal point right here. So it actually has 1, 2. And this one has 3. So we can only keep 2 sig figs because this has 2 is our least amount. So if I look, we have 1 and we have 2. So our final answer is 2.4 molar solution of FeCl3. Sorry that my handwriting is worse than usual. I will be working on it. This is the best I can do as of right now. I will be working on it to try to make it a little bit better as we go. Okay? In the meantime, let's get to working on our next problem. So problem number 3. Reading up top, if a 0.075 liter solution contains 0.087 moles of CuCl4, what is the molarity? So let's take a look at it. We have liters is equal to 0.075 and moles equal to 0.0877. So not many at all. Not many moles at all. Then we look at our equation. Molarity is equal to moles over liters. So we just go ahead and plug in. So 0.0877 moles over 0.075 liters. So at this point, all we got to do is plug it into the calculator. I invite you to pause now to do so on your own time. Please make sure that you're actually putting these into your calculator and solving for it. Me solving equations in front of you is not the same as you doing it yourself. I know these seem easy right now, but when you're doing them by yourselves, you might need the extra help, might need the extra experience. So, erasing this once again to give us more room because I only have so much room on this. We end up with 1.169 molar solution of CuCO4. But that's not the end of it, because we still have to do sig figs. Remember, sig figs still matter. They still are important. So if we look, we have two numbers given to us. The first one has 2 sig figs. The second one has 3. So all we got to do is pick which one it is. Well, when we're doing sig figs, it's always the least amount. So it's going to be the one that's right in here. We know that it's going to be 2 because leading zeros, aka these boys, are unimportant. They don't matter because they're out in front. They're just placeholders. So what's important is these two, leaving us with just 2 numbers, 2 sig figs, giving us the answer of 1.2 molar solution of CuCO4. Make sure that you're taking all of this, writing all of this down. I know I can't check all your work as easily because I am many miles from you, but we can do this. Remember, your work is still important even if I can't check it. Okay, let's get on to the last one, and then we can, get out of here. So, last problem. How many moles of NaCl are present in 600 milliliters of a 1.55 molar NaCl solution? Well, this is where things get a little bit more complicated because we're not solving for molarity. Remember, we have molarity is equal to moles over liters. We already have molarity. So we're trying to find moles. So the easiest thing to do is before we get started is to find how we get moles alone. Moles is on top. It's being divided by liters. So how we get rid of something that's dividing? We do the opposite thing. So we're going to try to get it to hop the fence. So we're going to hop the fence by multiplying liters instead. That cancels out our liters, leaving us with liters times molarity is equal to moles, which is exactly what we want. We want moles by itself. So we have our liters is equal to 600 milliliters. Now, if you remember from our last change from milliliters to liters, it's just moving the decimal point to the left 3 times. If you can't remember that, that's absolutely fine. I'm not telling you that you can't do the long conversion. I'm saying if you can remember that, and if you have confidence in that remembrance, you should just say, hey, I'm going to move this decimal place over 3 times, giving me 6.6 liters. And then we have a molarity of 1.55 molar. So I'm going to plug that into my equation. We have 0.6 liters times 1.55 molar solution. So, put that in our trusty calculator. 0.6 times 1.55 molar. So I'm going to give you a second right here to answer. So the answer you should have gotten would be 0.93. Now that's a bad 9 moles. So 93 moles of NaCl. So if I was going to write that, the way you should write that in your notes and in every problem going forward, 0.93 moles of NaCl. And that is it. That's all there is to it. You might be asked to find liters at some point. Let's take a quick look at how to do that algebraically. If you're asked to solve for liters, you just have molarity is equal to moles over liters. You're just going to multiply liters over just like you did a second ago, leaving you with liters times molarity is equal to moles. And then you just divide molarity over, leaving you with liters is equal to moles over molarity. So that is all that we have right now. Make sure that you take your notes and send them to me. Try to upload them onto Classroom. If it doesn't let you, try again in about an hour or in half an hour. Remember, these aren't due till Monday, but at Monday at high noon, I do take the grades in. You may have noticed that I did that today as I was working on it. Please make sure that you get these uploaded. There is no EduPuzzle this time because the system isn't working the way I want to. Hopefully we'll get those up again next week. So all you gotta do is take your notes for now. Please send me a picture of the notes that you take. Please make sure you're getting your work in. I know that this whole system is difficult and new. I will try to work with anybody who emails me, but you have to contact me somewhere in some way. Please remember that I have a Zoom office hour. I believe this class's office hour is at 2, I want to say. You should see it in the Google Classroom. So whenever that is, you have the full hour. I will have the Zoom meeting on. If there's no one on there by, say, 2:40, I'm probably just going to turn it off just to save bandwidth in my own house. But if I have people in questions, we can continue having those as long as we need to, stretching on into the 3 o'clock, 4 o'clock hours. Hopefully not because my poor Wi-Fi, but we will do what we need to finish these questions. So that is it. Please stay inside, stay safe. Don't go out with people. This is not the time to be taking those kind of risks. Remember, the longer you stay inside, the sooner we can all enjoy going back outside. Have a good day. Stay inside. Stay safe.